So although we have created an abstract class, but we are not using any kind of runtime polymorphism in this example. All these bindings are compile time bindings. Why? Because we are not using any kind of pointer here. Okay, so as we saw in the lectures, we cannot create an object of an abstract class. So number n, this statement was giving us an error, but we can create a pointer to the abstract class. Okay, so this is valid. Let's run it. So it is giving us no error. We can very well create a pointer to a abstract class. Okay, so let me erase these statements for the time being. Okay, so here we created three objects: dec d, hex h, and oct o. Okay, so let us try to put the address of d in pointer n. Okay, so now this n contains pointer to object of class dec. Okay, and when I write n arrow operator show, then so let us first write n arrow operator set underscore I. Okay, and pass the value 10. So what will happen here? It will execute the set underscore I function. And is set underscore I function a pure virtual function or a virtual function? No, it is a normal function. So here early binding will take place and this function will be executed. Okay, and then when I write n arrow operator show, then late binding will happen and the show function which is there in class dec, it will be executed. Okay, so and in runtime polymorphism, the interface remains the same. Okay, so using the same function calls, we can execute different things depending upon the object to which the pointer is pointing. Now let us make the object to point to h object. Now it will execute the show function in the hexadecimal class. Okay, similarly, if I make this n to point to address of o object and the interface I copy, just copy the interface, this is same, that is why it is called polymorphism. Okay, so now it will execute the show function in class oct. Okay, so let's run it. So the first show function is running dec class, so it is giving us 10, then hex class a, and then oct class, it is giving us value 12. Okay,